Good day, everyone, and thank you for joining the webinar. Today, I'll be discussing charging and discharging connectivity for LEVs, that is light electric vehicles. We have a special focus on to discuss in charging and discharging connectivity for these type of vehicles, with a special focus on the challenges, requirements, and connector solutions that is currently shaping the electric two-wheeler and three-wheeler market. Okay. So my discussion is based on battery and charging systems connectivity, because in light electric vehicles, connectivity performance is no longer a secondary hardware choice. Okay. As vehicle power increases, charging becomes faster and battery architectures becomes more demanding. The connector becomes a system-level reliability component. That is the main point here. So, for example, for the Indian market, especially, this topic is highly relevant. Okay, so because India is one of the most dynamic environments for electric scooters, motorcycles, and three-wheelers, with different use cases, ranging from personal mobility to high utilization for commercial fleets. Okay, so that means expectations are very high for uptime, safety, serviceability, and cost efficiency. Okay, let's start. Here I'm going to talk about outlines of 5 areas. First is the main technology trends and field challenges. Second is the evolving market requirements. Third is the connector solutions. Fourth, application examples. And then finally, what Chogori is supporting this industry globally and locally. Okay. So let's start with the core trends and field challenges. Let me start with what is changing in the LEV market. One clear trend is the move toward high voltage platforms, including 120 volts more plus architectures, mainly to support faster charging and improve system performance, right? As soon as voltage goes up, the connector design becomes more demanding in insulation, for example. Thicker insulation, pin to pin distance clearance. Okay, we need to consider thermal stability and safety, things like this. And then, of course, at the same time, when voltage becomes higher, current requirements also are increasing. We highlight here that the connector now needs to support 100 ampere and above in real vehicle operation. This means the connector must handle sustained current without excessive temperature rise, right? So while still maintaining mechanical stability and acceptable insertion and extraction force, which we call a push-pull force on the connector. So another pressure in this challenge is the compact design. Okay, in two-wheelers and three-wheelers, packaging space is always constrained. So sometimes the battery is okay. Mostly batteries are located under the seat. Sometimes they are all under the feet. So OEMs, what I wanted to say is that has a higher power transmission in a very small or smaller footprint. But the downside is that we need to do this miniaturization for a connector, right? But miniaturization cannot come at the expense of reliability. Okay, so the challenge is not just simply to make the connector smaller, but to make it smaller while preserving electrical, thermal, and environmental performance. Okay, the one in the middle here is about environmental protection requirement. Here shows that we have water and dust ratings of IP67, 68, and 6K, 9K requirement. These are some of the expectations that are customers or the industry is expecting. Okay, that is very important, especially, for example, in India, where vehicles and batteries operates in dust, monsoon conditions, we have road splashes, heat, and frequent outdoor exposures, right? So connectors must continue performing in real field conditions, not just in ideal lab conditions, which all these connectors are being tested on, of course. So in the lab conditions, we can test it, but it's not really what the actual environment will be um, um, going to be performed. Well, so we need to also ask or talk to our um, um, to the OEMs to discuss how is this going to be used in the real world scenarios, right? So, for example, another point here is about temperature. Okay, we have a wide range of temperature of minus 40 degrees to 105 degrees Celsius. So even if many applications are more concerned with high ambient heat rather than extreme cold, that upper end thermal reliability is essential for battery discharge, fast charging as well, and those enclosed vehicle compartments. Okay, so the next challenge here is the ruggedness and the durability. For example, salt spray, okay, vibration, and high mating cycles. These matters even more for commercial fleets, for example, and swappable battery ecosystems, uh, where these are being used in repeated use. It can quickly expose weaknesses in the terminal or contact wear of the connector. It also shows problems in locking reliability, the plating of the pins, the quality, or its contact resistance. So finally, connectors are no longer just power interfaces, okay? So here on the right side, we highlight smart integration, including embedded temperature and current sensing and high-density interconnect needs for CAN bus, RS-485, and BMS functions. As you most know, that the batteries are we're working now is our smart batteries, okay? Right? So in other words, the connector is increasingly expected to support both power and intelligence in one integrated architecture. So for me, for an engineering point of view, the field challenge is to balance 6 things at once, okay? So 1 is power, 2, size, 3, safety, 4, the ceiling, 5, durability, and the 6 is cost, of course. And in a mature EV system, if one of these is weak, the whole customer experience suffers, right? So let's go to the next page here. This is the evolving market requirements. Now, let's move from the technical trends that we're talking about earlier to market requirements, okay? So here you see 3 pictures. Let's talk about these two on the left first. These are low power, low cost connectors where you can see that it has a charging cabinet here where it has output plugs of 2 different interfaces. This is to accommodate different batteries or different vehicles when you charge them. And then the one on the middle is commonly used in locations like China, where the connector itself is being the use connectors that are most commonly used in household appliances, right? So the application shown compares the trade-offs around maintenance cost and charging speed, charging safety, and interoperability. So one side of the market favors high interoperability and very low connector cost, but the trade-off shown is slower charging, for example, around 7 to 8 hours for a full charge, along with limitations such as non-waterproof, no BMS to simple BMS control. The model may look economical at first, but it creates risk in safety, reliability, and also user confidence. Okay, so on this last picture here on the right, it pushes for faster charging. Okay, so if you can see this, they're using those charging guns where you can see those charging infrastructures. We have compliance to standard. Sometimes they use a type 2, type 6, type 7, CCS, things like that. So they have unified interfaces, right? And they have more reliable performance because these are big connectors. They're not small, and they're designed to handle very rugged, and anyone can use it anyway. So a lot of people use this very fast, and then they don't care about it using it very carefully, so they just wanted to charge and go. That's it. So this gives a better functionality, but also comes with a higher maintenance cost, right? So the market challenge is not simply choosing low cost versus high performance hardware. It is finding the right life cycle cost model. That's the main point here. So in India, this life cycle view is especially important because fleets and battery operators and charging operators look at total cost of ownership, right? A connector that is cheap to buy but fails early, for example, it overheats, it burns up, or it causes downtime, is actually expensive over time. Okay, so let's go to the next one. So this is a charging for LEV swappable battery station type. So here we show a practical contrast of the two of the most common connector for swappable battery. The one on the left is the bottom connector, where sometimes you see this on the bottom of the battery. Yeah, bottom connector on the bottom of the battery. And the mating pair is where it is located in the vehicle, so that you just open up the seat, and then you just put all the battery that has the connector down, sitting, resting on its mating pair, right? And then once you finish discharging it, you go to the charging station cabinet, put it in the cabinet, get a freshly charged one. So that's the main point of this usage. The top connector is a different one, where you need to have the plug to connect it on the top part of the battery. Okay, so mostly the bottom connector does not have a lock. Okay, it depends on the weight of the battery pushing it downwards. Okay, a connector without a lock can easy to operate, and it is low cost because you don't have much more parts in there. But the downside, it has a weaker vibration performance. Okay, especially if there's no proper hold on the battery to the vehicle. Okay, once there is vibration present, nothing holds them together. It has these tolerances that needs to consider that it can move, and then it scrapes off the surface of the terminals. That is what we wanted to avoid. Okay, and then the maintenance cost becomes very high because this goes under frequent swapping. Okay, we often give warning that if one connector burns, or one connector fails, or maybe scratch up, it can quickly affect others. If you use that, for example, a battery that has a failed pin, and then use it on a vehicle, and then use it to charge it, and it's communicable. It's like a disease that is going to also scratch both of the others. And then this is going to be passed to different vehicles. So what I try to say is that for this, a quick connector replaceable solution is one of the things that needs to be considered. Okay, so that we don't, if connector breaks, easily to replace. So that is the bottom connector. So on the contrast, on the right side here, it has a cable, a connector with cable, has a locking mechanism. It improves anti-vibration performance and reliability because once it's connected to the top battery, it moves once the battery vibrates. It moves together with the battery because it has this a cable that has this slack of cable that moves together. It's not pulling it out. It's not tugging it. So it requires, the only downside is it requires more steps because you need to push the lever to unlock or turn the nut to unlock. So what I'm trying to say is that in high cycle swap systems like this, convenience matters, right? But consistency and failure of the containment of the failure, it matters more. So we also highlight the lack of standardization about these kind of connectors. I think it's one of the major problems in swappable battery systems, especially because between the top and bottom connectors, these are the main issues here. So in India, where we see we have multiple battery swapping business models there, right? And they are developing in parallel interface inconsistencies, right? It creates a high quality risk of interconnection across many different systems. So that is one of the problems. So let's move to the next one. Okay, so this is a strong point talking about connector cost efficiency. So this also a little bit more, yeah, it is important because, as you know, gas prices goes up, a lot of different things goes up in terms of cost as well. So here we identified 4 major cost drivers. One is tax. The second one is freight cost. The other is maintenance cost, and then material cost. So for example, a basic customs duty can be around 10 to 15%, right? Which we can manage this through, for example, a localized manufacturing, or deal with the country where it's manufactured with free trade agreements, right? Okay. Freight costs, it can be reduced by using sea shipments, for example. And then we have this, what we call a CKD, a complete knockdown design, where a connector and cable don't need to be shipped out altogether, because the cable is like 80%. It costs like 80% of the whole width of the whole product. So we have this connector where we can supply the parts of the connector to the OEM, and OEM will be able to assemble it themselves, buy their own cable, and then can use it on their side, assembled it on their side, right? So again, another one is about the maintenance cost. It increases when connector issues and defects occur, right? Then it reduces equipment and battery life. So a quality connector product is very important here. And also, if we have a connector design where it is replaceable, easily replaceable, like I was telling you earlier, this will solve the issue. And another point is the material cost, where material cost is mainly driven by the copper alloy material, metal, specifically copper usage. We can have like when the design is or the connector design is being made, we try to optimize the copper usage to minimize it, so that we can have a good design where we can optimize the usage and at the same time maintaining the maximum current carrying capacity. Okay, so what I'm trying to say here, the cost optimization should not focus only on unit price, because there are different points involved here. A good connector design can reduce copper use intelligently. I mean, you can cut freight weight, can lower maintenance events, and improve life cycle economics. That is where engineering and the commercial strategy comes together. Okay. page, this is the connector solutions. We have some introductions. Okay, here we introduce a charging solution type 6. So it is compliant with Indian standard 170.172-6 with an IEC standard as well. This goes up to 10,000 bending cycles and 10,000 mating cycles. Okay, so the charging solution type 6 comes with two options, with the slow charge and a fast charging one, where the slow charge usually comes together with the vehicle to charge it at home. So you can also see the rated currents where different currents are used for slow charge and fast charge as well. So, okay, that is the 10,000 and bending and mating cycles is very important reliability signal, because these products must survive repeated real world handling, right? So, because this is not just one-time installation, so you need to have a very robust connector. So the next product is the charging solution type 7. Okay, so it has compliant with Indian standard 170.172-7 as well. It supports rated voltage 120 volts DC for power. The current is 25 ampere to 100 amperes. IP55 mated, 10,000 mating cycles as well. So the special thing about this connector is it has an easy maintenance replaceable power pin. Let me just show you quickly how this works, okay? So if you can see here that this type 7 connector, a lot of these are being used at very high frequency. And then these contacts can or may worn out. Okay, may worn out. So we have this design option where it can be replaceable. It has replaceable pins where it can also be replaced on site, for example. So the main components for the first thing that is going to wear off will all be replaceable, including the O-rings. So this is what is trying to do, removing the connector insulator there, or the connector head, basically removing the worn out pins and then changing it to a fresh one. Okay, so this, guys, is what we call a replaceable power pin design. Okay. Okay, so in high usage changing environments, serviceability can directly affect operator cost and downtime. Instead of replacing the full connector assembly after contact or wear or damage of the pins, a more maintainable design can help preserve uptime and reduce service costs, right? So, okay, so let's show you another one here. This is the battery power solution CM06 2+8. This has its own specification. The rated voltage is 160 volts DC for power, 80 volts for signal. So if you can see here, the rated current is much more higher than those charging guns that we're talking about earlier. This goes up to 150 amps and 5 amps for the signals. The peak current can go up to 200 amperes 60 seconds with standing voltage of 1500 volts and the insulation resistance 500 mega ohms. So the point here is that the design of this connector highlights not just IP67 and IP69K, it is 20% smaller than the comparable products, okay, and has 150 amperes continuous current capability. The product is relevant because we have thought this out. It reflects the direction of integrated battery connectors for LEV, right? Like, for example, it has high current power transfers, it has auxiliary signal channels for the pins, compact dimension, and a strong environmental protection in a single package, okay? So for OEMs, this means fewer compromises between electrical performance and packaging space. So it's a good solution and can be used for higher power requirement for electric vehicles. So that is CM06. Let's go to this. This slide is just talking about the Chogori's roadmap for battery power solutions. The company plans reliable, low-cost, high-power connectors. Okay, 2027, and we are planning for reliable top-bottom connectors for swappable battery system, because a lot of our customers are going this way as well. So this shows where the next development pressure lies, right? Not just higher performance, but standardizable. We need to think about standardizable. Need to be robust as well, and cost-optimized interfaces for large-scale battery ecosystems. If we are framing this for you guys, the industry experts, I would put it this way. Okay, the next connector generation for two-wheelers and three-wheelers must combine 4 design priorities. One is high power density. Okay, the second is high mating durability, high environmental robustness, and fourth, it needs to be field-friendly maintenance. So the important is that reliability is very important. Okay, reliability and repairability is important. So those combination is what determines real scalability. Okay, so here we just show you some application demos and success stories. It includes fixed battery examples. For example, this one here, it's a fixed battery. Again, fixed battery. There are detachable batteries also, you can see here. These are important because India's market will not be sold by one battery architecture alone. Okay, unfortunately, this is where we're at, or where it's going also. So fixed battery and swappable battery models will likely continue side by side. Okay, depending on which vehicle segment and operating model. So this is where it's at right now, and in the near future as well. So the fixed battery section, it includes examples of battery systems from brands such as TVS and also Honda right here. So this suggests alignment with more conventional integrated vehicle architectures, where the connector has to deliver stable charging and discharge performance over a long vehicle life with limited service disruption. Okay, quality is the key here. So others just show you examples, as you already know most of this. This is the bottom connector, swappable type, and then the top connector, swappable type. Okay, yeah, this is the charging cabinet, as you all know. Okay, so okay, let's see. So in a commercial three-wheeler and fleet environments, this becomes even more critical, okay? A single connector issue is not just a component failure. It can trigger battery downtime, system maintenance, customer dissatisfaction, and operator revenue costs. This is why connector design must be evaluated at the ecosystem level. So for all these connector designs and connector points of top and bottom connector, there is just one message that I wanted to emphasize to you guys. A good connector is invisible when it works, right? You don't see it once it's just working properly, but a connector is extremely visible when it fails. Okay. Yeah. So in light electric vehicles, the connector sits at the intersection of every energy transfer and data communication. So user handling also and environmental stress. So take note of that. Okay, so let's talk about the Chogori's commitment and positioning in the industry. So here is actually the final section. Okay, the company Chogori, the technology foundation is built on robust R&D, a broad product portfolio, an efficient production, and a strong local sales network designed to support the electric two-wheeler market. The company offers connector solutions for low to high power connector solutions. And then with the 7-day preliminary solutions and APQP based quality planning and scalable manufacturing under IATF 16949. So that is Chogori right there. Okay, so here is Chogori. Our HQ is located in Shenzhen, China. Our biggest factory is in Dongguan, China. We also have a factory in Thailand. And then we are excited to announce for India specifically by the end of the year, a localized factory of Chagori, India under Kechu Connect Private Limited in Bangalore. Okay. So the local presence matters because in this market, responsiveness, of course, application support, and engineering coordination are often just as important as the connector specification itself. So we are here, and soon we will be there. Okay, so guys, thank you very much. To close this, you know, um, the LEV industry is moving toward high voltage, high current, like what you have just shared in the poll, right? And more demanding field use, of course. That means connector systems must do much more than provide electrical continuity alone, right? They must deliver safety, sealing, durability, serviceability, and cost efficiency across the full operating life. So, for India's two-wheeler and three-wheeler sectors, this is especially important because scale, climate, fleet usage, and evolving charging and swapping models all increase the consequences of weak interconnect design. Okay. The opportunity is large, but the hardware must be designed for real operating conditions from day one. Okay, so guys, thank you very much for your time and attention. We at Chogori will be looking forward to the discussion and to exchange views on how connector innovations can be better to support the next phase of LEV growth in India. So, yeah, thanks again. Priyakshi, back to you.